Dear everyone, this is an honor for me today to have opportunity to present at the IoT Virtual World Forum on Internet of Things 2020. Today, I would like to introduce our paper titled Witness-Based Approach for Scaling Distributed Ledger to Massive IoT Scenarios. This is the joint work between me, Lam, Israel, and Petar Popovsky. We are come from the blockchain group connectivity section at the Aalborg University. This is the structure of our talk today. Now we wanna go into the first part of of this talk. In this paper, we propose a lightweight distributed ledger scheme for massive IoT scenario. We redefine the traditional blockchain transaction into two types. The first one is a global transaction. The second one is a local transaction. As you can see on the figure on the right hand, this is the conventional IoT system where the IoT device will connect with the central server via base station. And this is the global blockchain. We are introduced the witness system. Here, separate the physical IoT system with the global blockchain. For example, the local transactions generated from the IoT device which are connected with the same witness and the local transaction will process at the witness system, not global blockchain system. And the global transaction is that the transaction generated from the IoT device which are connected to different witness. So the global transaction will be processed at the global blockchains. And the main goal of this study is that the first, we improve the scalability of global blockchain by introducing the witness system. The witness system will process amount of local transactions for the global transaction for global blockchain. And the second one, with the witness system, it will have to increase the transaction per second and the confirmation time of the system. Now we move to the next part. But before going to detail of witness system, I would like to talk a little bit about the distributed ledger. Ideally, block distributed ledger is a truthful, immutable account of history of transaction and identically understood by all participants. But in reality, this is a approximation of the idea due to the non-zero delay in writing in database. When we talk about the distributed ledger technology, of course, we need to talk about the consensus. It means the node will support by highly non-trivial acquisition of the right to create an update, and the smart contract will modify the state of the database through a predefined set of functions and a chain. Mm, yes, by integrate with the emerging of blockchain, we will train the communication traffic in wireless IoT connectivity. With blockchain, it will have to increase the security and trust, but of course, it will add an additional overhead. For example, you can see this is the network with this is the traditional IoT network with the blockchain, and here the IoT network with blockchain. But even if the blockchain have to increase the trust and security of the IoT network, but it still have a big problem about the scalability. For example, now when IoT device want to join the blockchain network, the first scenario is that each IoT device have to become a peer of the or a client of the blockchain network. But you know the IoT device have the problem with the, for example, the IoT device considered like the resource constrained device, so it cannot store whole ledger of the blockchain. A second scenario is that a number of devices are grouped together to join, and a group of blockchain will become one client or one peer of the blockchain network. But you know the number of IoT devices increased significantly. For example, now we have to around, for example, if we have 20 billion devices and each device generates 10 transactions per day, so totally we have volume of 200 billion transactions. So it's a big number. And the question is that how to handle the ledger size efficiently and address the chances increase the transaction rate of the system. Um, to answer this question, we introduce a white block based on a white block is mean the widest approach for blockchain. And then, as I mentioned before, in the web block, we redefine the traditional transaction of blockchain into two types: the local transaction and global transaction. With the local transactions, the transaction generated from either device, which are registered with the same witness, and the local transaction will store at the local ledger and process at the local ledgers. And the transaction can process locally into as a winning system without going out to the global blockchain. But another transaction type is global transaction. In the with the the global transaction generated from the active register with a different witness, and the global transaction will store at the global ledger, and it must process at the global blockchains. So we can see the difference with the traditional blockchain. Here, this global chain will be processed at the global blockchain. You know, so the next problem is that, for example, each IoT device, here we have the one, two, and three IoT device. Um, each IoT device will have a list of we need to connect with, and to choose the witness to connect with, we propose a heuristic witness with selection algorithm. For example, now IoT device will select one of the available witness with the probabilities and transmit the transactions to the witness connect. And then if the link, the wireless link between the IoT device and witness is not in outage, so the transaction it will be transmit and confirm. Otherwise, the witness will select a new witness uniformly and at random and transmit the transaction to the connect with witness. This is the case because, um, for example, if the IoT device one connect with the witness one, but certainly the link between the IoT device and witness is broken, so it will lead to the failure of the transmission. So IoT device one need to have another. We need to connect, for example, number two or number three to connect. Yes, by formulate the Winnie system, we are propose a queuing model. For example, the first one, the link between the IoT device and Winnie formulated by we are formulated by the patch load model, and we compute the output probability here is a connectivity between the IoT device and Winnie. The second one about Winnie, we propose a MHQ21Q model to compute the confirmation time and the number of transactions in the queuing and the number of transactions processed at the global or local channel ledger. For example, here when the transaction go to the, we have the unit 1 to unit n, it will separate in and process as a server. We have, for example, if the transaction is a local transaction, it will process at the locally, and then if the transaction is global, it will put to the global blockchain. About the performance evaluation part, we are doing the experience in the area of 100 meters square with a 500 number of IoT device, and we vary the number of units from 2 to 10, 10 device, and we set up the block size of blockchain is one transaction per block. We can see that on the right hand, the maximum transaction generation rate per IoT device. We compare between the traditional blockchain and various number of witness, for example, number witness equal 2, 4, and 8. We conclude that the ratio of transaction processed at the global blockchain and at the witness system as a function of number of witness. For example, the number of witness varies from 2 to 20, and the ratio of transaction here at the beginning we compute the number of transactions in the queue, and then we compute the number of transactions in the global blockchain and number of transactions in the local block the local in the witness system. We can see that with increasing the number, when we increase the number of witness, the number of transactions, the number of global transactions will be increased, because if we have a multiple witness, so this means that the number of transactions, the number of global transactions will be increased, because the number of IoT device connect with the different witness increase. And finally, we compute the mean transaction confirmation between the traditional blockchain with the web block, and we vary the number of we need, for example, with the number we need equal 2, 3, or 4. You can see that the number of with the traditional blockchain, the mean transaction confirmation time will increase significantly with the number increase of the arrival rate. But with the winning system, we will the confirmation time will be decreased because um, the number of transactions go to the global blockchain will be reduced. Thus, global transaction will be go to the global blockchain, and the local transaction will be processed at the winning system. That's the reason why the confirmation time decrease compared to traditional blockchain. Similarly, with the larger size, we compare between the traditional blockchain and blockchain with web block and the local chain of the witness system. For example, in the larger size of the of the blockchain will increase with the number of transactions or with the number of increase of block size as well. But with the web block system, the ledger size will increase will be decreased because, as I mentioned before, thus the global transaction go to global blockchain. The local blockchain will handle and address the local transaction, and the this is the black light here is the local chain, the side of the local ledgers. Finally, we in this work we present and evaluate a performance of a novel witness-based blockchain system for IoT application. We present the web block, an IoT-friendly distributed system that incorporates a witness system to address scalability issue of blockchain. And the scalability provided by witness are achieved by processing some of transactions generated by the device locally at the witness system. With the witness system, it can reduce the number of transactions transmit to the global blockchain, and we reduce the confirmation time. In the future work, we plan to implement our web block system with the narrowband Internet of Things. As one of our work is about the integrate within the blockchain with the narrowband I mentioned here. Uh, yes, thank you very much for watching.